This is Algebra 2 at Trig, working on 13.1 using trigonometry of right triangles and our 6 trig functions. We're very familiar with 3 of those we've recently done, but now we're going to talk about another 3. So we have 6 trig functions. First of all, we're going to refer to theta. Theta is a Greek letter. Let's make that a capital G, that'd be appropriate. We have a Greek letter, and it's a variable that stands for an angle. So as you move on to higher level maths, you'll see that a lot. When you get a formula, if it has the theta symbol, you're very confident that that's going to be an angle value that goes into that, rather than using x or a variable a. We use the theta because that's specifically to an angle value. So what we know from before is that our trigonometric ratio is a ratio of the lengths of 2 sides of a right triangle. We use words like opposite, adjacent, and hypotenuse to describe these words. We've learned about sine, but we abbreviate that S-I-N, but that's still pronounced sine. We have cosine, and we abbreviate that S-O-C. And then, of course, we have tangent, and we abbreviate that T-A-N. So those are your 3 trig functions that you're most familiar with. We have 3 new trig functions to talk about. We have secant, which is abbreviated SEC. We have cosecant, which is abbreviated CSC, and we have cotangent, which is abbreviated COT. Again, when you read those letters, CSC, you don't pretend to pronounce that. You pronounce that as cosecant. What you are familiar with in terms of the ratios themselves, if you think about SOHCAHTOA, that helps you remember your 3 trig function ratios, that sine is the opposite over hypotenuse. You know that cosine is the adjacent over the hypotenuse. And of course, tangent is opposite over adjacent. So those are your 3 trig functions that you are most familiar with. Now you're looking at 3 more. And you're wondering, how am I ever going to remember 6 of these? Well, actually, sine and cosecant are related to each other. Cosecant is the reciprocal. So it's just the hypotenuse over the opposite. Secant is related to cosine. They are reciprocals of each other. We have hypotenuse over the adjacent. And then cotangent and tangent, in their names, you can hear it themselves. Those are related to each other. So adjacent over opposite. So the trickiest part is being able to identify which new term goes with the term you already know about. Cosecant goes with sine. How are you going to remember that? What I would suggest, or the way that I think about it, is both of these have an S and a C with it. And then down here, it has an S and a C with it. Unfortunately, the S's don't go together. They're not reciprocals of each other, and the C's aren't reciprocals of each other. So it's not quite that simple. But in terms of it, they both start with an S and a C. So you have a pair that's matched that way, and you have a pair that's matched with an S and a C. Okay, so you'll see that in the future here when we say, if you're given the sine ratio, you can then write the cosecant ratio, because this starts with an S, so you know the one that starts with a C is its partner. So we'll come down and we'll write all 6 trig ratios when we're given this triangle. We're given this triangle with theta, so that's the angle that we're going to refer to. So when we look across from that, we see the 7, which would be considered the opposite side, the 24, which is considered the adjacent side, and then across from the 90 is considered the hypotenuse. But we don't have that hypotenuse value. So first we've got to calculate the hypotenuse. So using Pythagorean theorem is how we could go about that. We can't use sine, cosine, or tangent to solve for it because we don't have the hypotenuse and we don't have the angle. We might be able to calculate the angle, true, but right now we would have 2 unknowns. We couldn't go directly to the hypotenuse. So this is one way you can solve directly for the hypotenuse. You don't need the angle. If you have 2 sides of a right triangle, you can use Pythagorean theorem. So hypotenuse squared equals 7 squared plus 24 squared. We don't know the hypotenuse, so that stays HYP. HYP squared. 7 squared is 49. 24 squared is 576. That's going to add up to equal 625. Now, if you know your numbers, you start to realize that 625 sounds somewhat familiar. It's because you can take the square root of 625, and that is a perfect square of 25. 25 times 25 is 625. So here we have 7, 24, and 25. That is actually a Pythagorean triple, obviously. 3 numbers, all made of whole numbers that satisfy the Pythagorean theorem. If you recognize that from the beginning, you can save the steps. So those are the advantages of knowing your Pythagorean triples. 3, 4, 5 is a very common one. 5, 12, 13 is a very common one. And this would be another one that's most common. Okay, there's a few other ones that have small values involved with it. And they just get bigger and bigger. So there are lots of Pythagorean triples out there, plus all the multiples of that. So 14, 48, and 50. That would be a Pythagorean triple. Sometimes those are a little harder to recognize, just to let you see that connection. All right, so what we're going to do, we're going to talk about and list all 6 trig ratios to theta. So we'll typically start with sine. So sine of theta. We don't have the specific angle. So it's just sine of the theta. We know that that is opposite over hypotenuse. So in this case, that's 7/25. So you go ahead and fill out the other 5 trig ratios. Using a video, you can pause the video, try out your ratios, and then come on back. So next we have the cosine of theta. From theta, that's going to be 24/25. We could do tangent of theta, which is the opposite over adjacent, opposite and adjacent, which is 7/24. Now we've got our other 3 trig functions. Since sine starts with an S, I'm going to look at the new trig ratio that starts with a C. So that would be CSC of theta, cosecant. And that's going to be the reciprocal of sine. Cosine starts with a C. So it pairs with the new trig ratio that starts with an S. So cosecant goes with, or cosine goes with cosecant. So that's going to be 25/24. And of course, tangent goes with cotangent. That's 24/7. So let's try that one more time, working with our new terminology. You go ahead, fill it out. You can pause again, come back and check how you're doing. So from our theta, we're looking for our adjacent side. 15 would be considered your opposite side because it's across from it. And of course, across from the 90 is your hypotenuse. So we have our 17 squared, our 15 squared, and our unknown, if you like to call that a variable, x is pretty common. So we have 289, 225, x squared. We need to subtract across to get 64. And when you take the square root of 64, you get 8. So this is actually another Pythagorean triple. 8, 15, 17. Not nearly as known as like a 3, 4, 5 triangle, but nonetheless, Pythagorean triple. So looking at theta, we can easily figure out sine, which is the opposite over hypotenuse, and cosine, and tangent. Then we're getting used to writing out cosecant, which is CSC. That's the reciprocal of sine, 17/15. Then we have secant. And then cotangent. The more times you say the words, the more times you write it out, the more you're going to be familiar with it. So those are your 6 trig ratios. You can now see why we've only learned 3 in the past, because we used these 3s to solve for a missing side. Now we see that the other 3 are just reciprocals of the first 3. We wouldn't really need those to solve for a missing side. So here's a way of asking the same type of question, but making it a little step higher. If we have theta as an acute angle of a right triangle, And we know that cosine of theta is 3/8. We want to know what cosecant of theta is. So at first you might be thinking, hey, it's reciprocal. It's 8/3. But then you notice, wait a minute, these both start with C. All right, we've talked about how the ones that are related like that, ones that are reciprocals, one starts with a C and the other one has to start with the S. So the secant is 8/3. So it's not cosecant. So now I don't know what it is. So what might help is if you start out with a right triangle. It doesn't really matter how you label your triangle, as long as you're focusing that cosecant. Actually, sorry, this is cosine. We have cosine is adjacent over hypotenuse. Cosine has the 8 for the hypotenuse. That would be required. Now, it doesn't really matter where you put your 3 as long as theta is related to it. Now, since my 3 sounds like a pretty small number, I'm going to place it here. So that seems to be a short side of my triangle I wrote. Therefore, I need to put my theta so that the cosine is adjacent over hypotenuse. Now I have to solve for the missing side. Well, I have 8 squared equals 3 squared plus my missing side, which you can call that x squared. So that's 64 equals 9 plus x squared. When we subtract the 9 to the opposite side, we get 55. Well, that's x squared. So the square root of 55 is just x. And as we think about square root of 55, we think about breaking that apart. That's just 5 times 11. Right? But that's not a pair of numbers. And nothing can be broken down more. So that doesn't reduce any further than square root of 55. So that is our long leg. It's a little bit more than 7 because it's larger than the square root of 49. So we know that cosine is 3/8. We would know that sine would be root 55/8. You could write that if you wanted to. I'm just going to focus on getting down to cosecant. Cosecant is the reciprocal of sine. So yes, I need to figure out sine first. Sine is opposite over hypotenuse. Sine is root 55/8. Cosecant, one starts with an S, one starts with a C, is the reciprocal of that, 8/root 55. But when we look at that, we say, wait a minute, that has a radical in the denominator. So I'm supposed to rationalize the denominator. So I get 8/root 55/55. And that's my final answer. You've got to be sure you write your answers in simplified radical form. So what did we do? We found the missing side of our triangle, so we could calculate the sine of theta because we need to do the cosine of theta. You go ahead and try the next one. So when we look here at our next one, we see that the sine of theta So 8 and, or this is 10 and 6. Thinking about what our numbers would possibly be making that, I can imagine that the 6 is going to be the smaller side. The 10, of course, has to be the hypotenuse. So that helps me put my theta here. But if you're not really certain about that, it doesn't matter if you have your triangle drawn proportionally or not. Okay, you just need the 10 to be at the hypotenuse, and you need the 6 to be opposite the theta. That's really the only requirement you've got. All right, so I'm trying to find this missing side. If you know your Pythagorean triples, you can use that, but I assume the majority of you said 10 squared equals 6 squared equals x squared. 100 equals 36. Subtract your 36 to the other side. You get 64. And that comes out to be 8. So yes, that is a Pythagorean triple. But if you look at those numbers, it's 6, 8, and 10. If you divide them all by 2, you get 3, 4, 5. So that's what you're really trying to recognize. If the hypotenuse is a 10, okay, and the short leg was that 6 was double the 3 and double the 5, you know the final side has to be double the 4. Anyway, if the sine is 6 over 10, I can calculate the cosine would be adjacent over hypotenuse as 8 over 10, which can be reduced to 4/5. And that would be the best way to write your answer. 4/5. So we took the information they gave us from the beginning to develop a triangle so we could find the missing side. And then we were able to write our trig function. It would have been much more exciting if they asked us for a secant or cosecant or something like that. But cosine is just the same. All right, moving on to a little bit more of these right triangles. Here's our 30, 60, 90. All right, and there's some rules that go on with these special right triangles. You know that the pattern of an isosceles triangle is x and x. For a 45, 45, 90 triangle, it is an isosceles triangle. The legs are both x's. And the hypotenuse is √2 times that leg. So when we look at this and we go from an angle and we look at the opposite and the hypotenuse, we look at the sine of that, opposite, hypotenuse. So the sine of 45 equals x over x √2. Right, and this would work for any set of numbers, right? This is just the pattern. So if it was 3 for a side, it'd be 3, 3, and 3√2. It'd be the same idea. The sine of the 45 would be 3 over 3√2. Which is 1 over √2. Which we need to rationalize the denominator, and we get √2 over √2. So the sine of 45, we can come down to our chart right now, and we can fill out our chart that the sine is going to be √2 and 2. And I know that the cosecant is going to be the reciprocal of that, which is 2 over √2. Well, I have to rationalize the denominator, and that gives me 2 √2 over 2, which comes out to be just √2. We got both of those answers just by using the sine of 45. And we know the cosine of 45 would be using those same values again. It would still be adjacent over hypotenuse, which is x over x root 2, which simplifies in the same format. And the secant would be the same result. It would be root 2. For the same reasons. Then the tangent. If we come up here, okay, we know that the cosine of 45, that's going to equal root 2. Let's see, what did I write before? This would be root 2. I'm sorry, I wrote root 2 over root 2, right? But wouldn't that be 1 times root 2 over root 4, and root 4 is 2? So I wrote that with a radical. All right. Now, was it making sense to me when I was doing my calculation here? So the cosine is the same thing because it has the same ratio. So I'm not going to redo the calculation. We're starting to recognize those. Tangent of 45 is going to be the x value over the x value. It's the opposite over the adjacent. It's x over x. So that's just the value of 1. So tangent of 45 degrees, you can come down to your chart, is 1. And the reciprocal of that is just 1. Any questions on where I'm getting those from? All right, now we're going to look at the special right triangles for 30, 60, 90. We know that the relationship is that the short leg times 2 is the hypotenuse, and the short leg times root 3 is the long leg. So let's see if we can get this to fit in here. When I do the sine of 30, that's the opposite over the adjacent. That is x over 2x. How's that going to reduce? The x's would reduce, and you'd get 1 over 2. That's how we determine if our calculator is in the right mode or not. We do sine of 30 and we get 0.5. So down in your chart, you can put down 1/2 for the sine of 30. The cosine of 30, would be adjacent over hypotenuse. That is x root 3 over 2x. That's root 3 over 2. Now, those two values right there, 1 over 2 and root 3 over 2, those are most of your answers on the unit circle. If you know those two numbers, you know all the answers on the unit circle. So you can put that as your cosine of 30. Now, using the same pattern, sine of 60, that's going to be root 3 over 2, because that's going to be the sine of 60 is opposite over hypotenuse, which is x root 3 over 2x. And the sine, or the cosine of 60 is adjacent over hypotenuse, x over 2x, so 1/2. So you can try that actually in your calculator. You can do cosine of 60 and you'll get 0.5. And then we can do the reciprocals of those to fill out the rest of the chart. How about the tangent? The tangent of 30 is opposite over hypotenuse, or I'm sorry, opposite over adjacent. So we have x over x root 3. Well, the x's cross off, and we get 1 over root 3. And we have to rationalize the denominator. So when we do that, we'll get root 3 over 3. And the tangent of 60 is x root 3 over x. That is just root 3. So now we can come down, if you haven't already, and fill in the rest of your chart. That the sine of 30 was 1/2. So was the cosine of 60. So the reciprocal was 2, and the reciprocal was 2. The sine of 60 was root 3 over 2. So was the cosine of 30, root 3 over 2. So the reciprocal was 2 over root 3. And yes, you have to rationalize the denominator, and you get 2 root 3 over 3. Now we're going to get 2 root 3 over 3 for the same reason. Then the tangent of 30 we saw was root 3 over 3, and tangent of 60 was root 3. The reciprocal of that is root 3 over, is 3 over root 3, and we rationalize that. That comes out to be 3 root 3 over 3, which is just root 3. Which for the same reason is going to make this root 3 over 3. So now you have filled out your entire chart. This is the unit circle. Okay? And you see the same numbers being repeated again and again and again. The unit circle is going to focus mainly on sine and cosine. So 1/2 and root 3 over 2 are your major answers. Root 2 over 2 does happen whenever you have the 45s. Okay. Now to finish up, we have these special right triangles. Now we could use the formulas. We could use hypotenuse equals the short leg times root times 2 to answer the 30, 60, 90 triangle. Okay, and the long leg equals the short leg times root 3. You could totally do that. Is there another method to solving for sine or for x and y? Well, x is the opposite side of the 30. Okay, so going from 30, opposite over adjacent, that's going to be tangent. So tangent of 30 equals x over 8. Now, if we did that in the past, we need to use our calculator and we'll get a decimal. But now we know what the tangent of 30 is. You can look up in your chart. Tangent of 30 is root 3 over 3. And when you cross multiply, you only have to cross multiply in one direction. That's going to give you 8 root 3 over 3. Now, if you think about that, that would have been the same thing as if you took your 8 and you divided by root 3, and then you rationalize your denominator. I'm not quite sure this is faster, but it is a little bit different focus on what you're looking at. This is how you want to be thinking about the sine, the cosine, and tangent of values in the future. Not to require yourself to go to a calculator, but to quickly be able to consider what is the sine, cosine, or tangent of your angle. Okay, so now we're going to look for y. You can go from any of the angles you want, it doesn't matter. So if you want to go from the 60 this time, you'd probably use your 8, the value they gave you. So from 60, that's the opposite in the hypotenuse. So now we're talking about the sine of 60 equals the opposite side over the hypotenuse. We know that the sine of 60, if you look down at your chart, is root 3 over 2, 8y, 8 over y. Okay, because your variable is on bottom, we have to crisscross here. We'll get y root 3 equals 16. Yes, unfortunately, we have to divide by root 3. And yes, we have to get 16 root 3 over 3. Well, I guess you could have used your rule that was times 2, huh? Wouldn't that have gotten your 16 root 3 over 3? Yeah, that would have been another way to answer this question. But when you're dropped just what is the sine of 60 in this situation, you would do your calculations in a similar manner. All right. Go ahead and give it a try with the next one. I know you have your shortcut method that we've used in the past. This isn't much different. Give it a try. See what you can figure out to be x. If we're looking for the x value, that would be the adjacent side and the hypotenuse. Because across from it would be considered the opposite of the 45. So we know we're going to use the cosine of 45 equals the adjacent over 6. We know from our chart that root 2 over 2 is the value of cosine of 45. So we'll cross multiply. And we get 3 root 2. Okay, what you're going to need to know in the future when we talk about the unit circle, you're going to need to know that the sine of 30 is a half and the cosine of 30 is root 3 over 2. I will talk to you and give you some geometric reminders about how that works and some advantages to that, but those are all part of the unit circle. Makes the unit circle really easy if you know them. Good job, everybody.